Okay, so today we're talking about triangle inequality theorem. This is so much better than 5-3. It's I don't want to say it's my favorite thing we do with triangles because Pythagorean theorem is far and away my favorite. However, I really do like triangle inequality theorem. I just think it's like a cool little trick to learn kind of how triangles operate. So the I can statements for today are: I can use the triangle inequality theorem to identify possible triangles, and I can prove triangle relationships using the triangle inequality theorem. So, what the triangle inequality theorem says is the sum of any two sides of the triangle must be bigger than the third side. So if you choose any two sides of the triangle, they have to be bigger than the third remaining side. So then they give us our three inequality examples. So in this case, they say PQ and QR added together must be bigger than our remaining side of PR. They say QR and PR must be bigger than our remaining side of PQ. And last but not least, they say PR and PQ must be greater than QR. So when they say this, so they tell us, oh, it has to be bigger than the third side. So theoretically, we would have to make three inequalities every time. In my head, what I think about is, okay, well, the hardest one to make is going to be the smallest two sides adding to the biggest side. So what I almost always do is I just check, okay, are the smallest side and the second smallest side bigger than the biggest side? If that's true, then we're good to go. So I kind of take that shortcut a lot of the time. But there will be examples where you do need to use all three inequalities, although they are few and far between. So just be aware that there are always three inequalities you can make. Okay, so a lot of example questions for this lesson will revolve around the idea of, can we make these three sides into a triangle? So it's pretty straightforward. You just need to set up your three inequalities. If they're all true, then you're good to go. If any one of them is false, then then it cannot be made into a triangle. So that being said, what I always start with is my two shortest sides. So I say 6.5 plus 6.5 has to be greater than 14.5. So I need to check this. 6.5 plus 6.5 is 13. So is 13 greater than 14.5? No. So can't be triangle because 13 is not greater than 14.5. All right, pretty straightforward stuff. Now, if we did want to check our other ones, we could say 14.5 plus 6.5 is, so that would be 21. 21 is greater than 6.5, and then our other one would be 14.5 plus the other 6.5, which would still be 21, and it's still greater than 6.5. So my trick of just always starting with the two smallest triangles, or the two smallest side lengths, will save you a lot of time in this. All right, so our next one, they want us to find out if it's possible to have a triangle with side lengths of 6.8, 7.2, and 5.1. So I'm just going to set up all three of our inequalities here just so you can see what this looks like. So I'm going to say 5.1 plus 6.8 is greater than 7.2. My next one is going to be 5.1 plus 7.2 is greater than 6.8. And then my final one would be 7.2 plus 6.8 is greater than 5.1. So right off the bat, we can simplify each of these, and I can say 11.9 is greater than 7.2. That is true. Check. Second one, we get 12.3 on this left-hand side, and that is greater than 6.8. That is true. And really, if we just looked at this as, well, 6.8's smaller than 7.2, so of course 7.2 plus 5.1 is going to be bigger than 6.8. And then finally, 7.2 plus 6.8 is greater than 5.1. Once again, each of those by themselves is bigger than 5.1, so of course it's going to work, but just to be tried and true, 14 is in fact greater than 5.1, so check. And then we of course write the classic statement of yay, it's a triangle. And of course, it's not just any triangle, it's a happy triangle. On the test, you get bonus points for drawing smiley faces on your triangle. Little known fact, very important to mathematics, smiley faces in shapes. All right, so we just continue with problems like this. Is it possible to form a triangle using the given side lengths? 8.5 plus 11.5 would be 20, which is not bigger than 20.5, so it would be no. Continuing on. 4.8 plus 12.2 would be 17, which is bigger than 15.1, so you could make a triangle out of that. Okay. Let's see, do we have one of these? Okay, no we don't. So I'm gonna want to go through a different type of problem with this. So we're just going to ignore these answers / this question. So we're gonna pretend that this question says, well, hang on, let me label my sides first. I'm getting ahead of myself. So PQ is 7.2, and then QR is 5.2. So those are our two given side lengths, and they tell us which measure cannot be PR. Well, that's straightforward. We can do that multiple choice problem. I have the utmost faith in all of you. However, you're going to get problems that ask you, they'll give you two side lengths like this, and then they'll ask, well, what is the range of sides for side RP? And so finding that is a little bit more tricky. So I'm going to walk you through the steps to do that. So we know side, I'm just going to call this side X. Side X has to be less than 5.2 plus 7.2. Okay? So it has to be smaller than 5.2 plus 7.2. And of course, if we add those up, we would get 12.4. So 12.4 has to be bigger than side X. So that's our upper bound. So the biggest it could be would be 12.39999 repeating. But now we have to find the smallest it could be, which that part's a little bit trickier and less straightforward. So if side X is not our biggest side, let's pretend it's our smallest side, because the smallest side would give us the biggest range of what those what the side length of RP could be. And so if we pretend RP is the smallest side, or side X is the smallest side, we could write the inequality, I'm going to switch to blue. We could say 5.2, if I could actually write that, 5.2 plus x has to be greater than 7.2. Okay. So now we can solve this to figure out what's the smallest possible side length for RP, or x as we've used it in this case. So in order to do that, we would subtract 5.2 from both sides, because when we're solving an inequality, we're operating kind of the same way as we do with an equation. It's a little bit trickier in some cases, but typically when we're just adding, subtracting, it's pretty straightforward. So in this case, we would say x has to be bigger than 2. So we would say the range of what this side could be would be, it would have to be bigger. So we would say x is greater than 2 and smaller than 12.4. Okay. Now I know that was a little disjointed and a little bit far-fetched, especially since it's not exactly what the problem's actually asking. But we're going to try this again with the next problem. So essentially what you're trying to do is you're going to set up an inequality pretending the missing side, which is this RP, you're pretending this missing side is your biggest side, and then you're going to set up an inequality pretending it's the smallest side. And then when you write your answer, you just put the smallest one on the left and then the biggest one on the right. Which we'll talk more about this in our lesson. But so let's try it again with this problem. So we have xy, which is 6, and we have yz, which is 9. So real quick, they ask us which measure cannot be xz. So let's just do that real quick. If I made xz, I'm just going to highlight that side. So if I made that side 4, we would have 4 plus 6, and that would be greater than 9, so that works. Same deal with 9, 9, 6. Those all work. 12 plus, or 9 plus 6 would be greater than 12, so that works. If we made it 16, 6 plus 9 would be 15, so it would not be greater than 16. So our answer for this would end up being D, if we were working it out the way the problem wanted us to. However, we're going to work it out the same way we worked out that last one, so we're just going to pretend this isn't here for a minute. Highlighter, blackout. All right, so if we were asked to find the range of what xz could be, side xz could be, we would need to find the uppermost point, so the biggest point it could be, and the smallest point it could be. So our final answer is going to be written as blank is less than x if I say this side length is x, which is just for ease of use. So blank is smaller or less than x, and then x is smaller than blank, so our biggest side. So if we pretend side x is our biggest side, then we know that 6 plus 9 must be greater than x. So we know x has to be smaller than 15 if I simplify that inequality. So the biggest number it could be would be 14.9 repeating. So we're just going to say x has to be smaller than 15. So that's going to be our upper bound, or our biggest number. And then for us to find the smallest side, the inequality we would set up would be, we would say, okay, if x is our smallest side, that means 9 is our biggest side. So we would say 9 has to be less than 6 plus x. And then we would go about solving this the same way we did in that last one to find our lower limit. So if we subtracted 6 from both sides, we would say x has to be greater than 3. So 3.1, 3.000000001 would all work. It just has to be bigger than 3. So our lower limit for this would have to be 3. So we know for this to be a triangle, the side length for xz has to be between 3 and 15. And we did that by solving for our lower limit and our upper limit, which was really just setting up two of those inequalities and solving for them. And then we wrote them as one single inequality here on the bottom. That's all there is to this lesson. If you have any questions, please do not hesitate to